Okay, so some of y'all are struggling, so I'm just gonna do as many YouTube videos as I can to try to help y'all out. And so this one's gonna be about the mole and Avogadro's number and molar mass. And so a mole, the definition is the amount of substance that contains as many atoms as there are exactly 12 grams of carbon-12. So a scientist got 12 grams of carbon-12 and figured out exactly how many atoms there are roughly and decided that that number is a mole. Okay, and so we can have a mole of anything. And so the definition itself, it's based off of a very constant, so it's 12 grams of carbon-12. So we can make sure that we're consistent and that that number is exact. But that's what a mole is. And the whole reason why we have a mole in chemistry is just because particles and atoms are so tiny. It is so hard for us to be able to conceptualize those numbers and be able to manage those numbers. The amount of atoms in this gold ring, this teeny tiny gold ring, is insane. And so we just can't conceptualize it. So we need something that we can readily handle and deal with. And that's why we came up with the mole. So the definition itself is a little confusing to kids, but just realize that a mole is just like a dozen. Okay, so that's the definition of what a mole is. And then we figure out what the actual number is. And the actual number is Avogadro's number. And so a person with the last name Avogadro discovered the number. So they're the one who came up with how many atoms are in 12 grams of carbon-12. And they figured it out that it is exactly 6.02 times 10 to the 23rd. That's how many particles we could say. So that number is huge by itself. So 6.02 times 10 to the 23rd. That is 602 with 21 zeros behind it. 3, 6, 9, 12, 15, 18, 21. So if you look here, that is how that number is. Okay, so that is why we write it like this. We just write it in scientific notation. But that's so many atoms. That's so many little individual atoms in 12 grams of carbon-12. 12 grams is not a lot. And so whenever we're thinking about that, atoms are so small and there's so many of them that make up everything. That's why we have a mole. So Avogadro's number is essentially, a mole is essentially like a dozen, to where it's just talking about that amount. And so how 1 dozen is equal to 12, 1 mole is equal to 6.02 times 10 to the 23rd. And so in this case, that is equal to 1 mole. And we typically abbreviate mole by just saying MOL. That's how you're going to see it whenever it's worked in problems. But that's what this is saying. And so this is Avogadro's number, and we equate it back to a mole. So that's how many individual particles are in 1 mole. And why do I say particles? Because if I'm talking about a molecule or a compound, that's how many molecules are in that compound. If I'm talking about an individual element, then we're talking about atoms. But just like with a dozen, I could be talking about a dozen people, and that would be individual persons, or I could say a dozen couples, and those are pairs, so I actually have 24 people, which would be 2 dozen. Or I could be talking about families, your basic 4-person family. That's like a standard mom, dad, boy, girl, or whatever, or mom, but 2 kids, it's typically just standard. So a 4-person family is like the average family, or at least it used to be. I don't know, I'm not into sociology anymore. But that being said, if I said I had a dozen 4-person families, I actually have 48 people. And so I can say I have a dozen families, I could say I have a dozen couples, I could say I have a dozen people, but it's all talking about 12. And so we can do the same thing with a mole. I could say I have a mole of atoms, which means I have 6.02 times 10 to the 23rd atoms. I can say I have a mole of molecules, which would be 6.02 times 10 to the 23rd molecules. I could say I have a mole of particles, or even ions. Okay, but it's still, if I have a mole of any of those things, it's still gonna be back to those. And so, just like if I said I have 6 people, we could figure out that that's half a dozen people. If I know how many particles, atoms, molecules I have, I can figure out how many moles. So we can go back and forth between the two. We can figure out how many moles or how many atoms, particles, whatever. So we're gonna use that interchangeably. So whenever you see these words, these are key words that you need to use Avogadro's number in problems. And we'll work some problems. Right now I'm just trying to make sure that we understand what we're talking about. Okay, and so molar mass is going to be talking about the grams per mole, because just like a dozen individual people is not going to weigh the same amount as a dozen families, right? Well, that's going to be a ton more people, and so it's going to have a bigger mass. The same thing is true with compounds and elements on the periodic table. They're all not going to weigh the same, and so they each have an individual molar mass that tells us, hey, this is how many grams per mole we have. People is a little less constant. If I picked a desk or a chair or calculators, I could figure out those. So if I knew each calculator weighed, a pound, then if I had 12 calculators, I know I'm carrying 12 pounds. If I have 100 calculators, it's 100 pounds. So I know when that weight becomes too much to where I can't carry it and transport it and things like that. We don't typically think about the weight of things, but if you ever want to go into like business and logistics, you would. But either way, molar mass is talking about the grams per mole, because each of these atoms, molecules, particles, ions, they all weigh a certain different amount than any other atom. Does that make sense? So carbon atoms weigh a different amount than oxygen atoms, and carbon atoms weigh a different amount than hydrogen atoms, and water molecules have a different mass than carbon dioxide, and so on and so forth. And so because of that, I can have a mole of oxygen, which means I have 6.02 times 10 to the 23rd oxygen atoms, but it's not going to weigh the same as 6.02 times 10 to the 23rd carbon atoms, because even though I have the same amount of them, they're different substances, so they're going to weigh a different amount. Just like my gold ring weighs a different amount than my rubber ring. So if I had 12 of these and 12 of these, they would weigh different amounts. So if I had a dozen and a dozen, they'd weigh different. If I have a mole and a mole, they're going to weigh different amounts. So everything is different. So we always need to look at our periodic table to figure out molar mass, and if it's a compound, we calculate it.